C++ programming for to implement the queue data structure. So we define a class. I name it myQueue. So this class has some data members like size of the queue, the front index, rear index, and an int type array pointer that will be used to dynamically allocate the array for this queue data structure. And we need here two pointers, two indexes front and rear, because the queue data structure has two ends. At one end the values are the entries are freed or exited, are served, while on the other ends the values are added. So at this end it will be dequeued, and at this end it will be enqueued. So here we define the constructor, and constructor should always be public, and it demands an argument of size will be assigned to size, and array will be initialized according to the size, and in start both front and rear will be set to -1. Okay, so now we write some functions of isFull and isEmpty. Bool is empty. The condition of empty is very simple. When both front and rear are -1, the queue is empty. If front is equal to -1 and rear is equal to -1, we return true, else we return false. Okay, and next we define a function for isFull. And the condition for full is when if rear plus 1 is equal to front. So this is the condition for being full. Like you can see here, when this queue is full, suppose there are some values here as well. Suppose there's value here and here. So now front is here and rear is here. So rear plus 1 will be front. Now at this time rear is 8. 8 plus 1 becomes 9, but since it's a circular array, circular queue, so 8 plus 1 will become 0. And similarly, suppose in this case, suppose this is rear and this is front, and we add more value to this queue. So what will happen? It will be move from here to here, and when more values, and rear will come here. So at this point 4 plus 1 is equal to 5 and the queue is full. So but for this situation we need to make it 0 again. So for this we can use the operator mod operator. So here we will do it programmatically as mod size. It will make it 0 again when it reaches at the end of the array. We return true, else we return false. And again, now we write the function of enqueue and dequeue. Void enqueue to enter the values, and new entries are always added at the rear, so we will increment the rear pointer. Here we check if the queue is full. We will not enqueue anything, we will simply display a message, queue is already full. Okay, else if queue is empty, what we will do, we will make these both indexes front and rear, we will assign 0 to these indexes, because when it will be empty it will have -1. So we make them 0, we take them to the 0 index, front, rear both are set to 0. So I added here else if, and else what we will do, we will simply increment the rear pointer because new entries are always added at the rear. And you know, when we will reach to the at the end of the array, it needs to be set, bring back to the beginning of the array. So to do that, we will take its mod with the size, and now we simply set the values of array with index rear. That's it. Oh, we need to have the value of that, we need to set it int n as an argument. So let me say, so this is the code of NQ, and next where the code of DQ. And DQ, you know, the item at the front will be served first, so front will be incremented. First we see if is empty. If queue is empty, we will simply display a message that queue is empty. We cannot DQ anything. Else, if queue has only one value means front is equal to rear. When queue has only one value, these both indexes are equal. You can check it yourself. What we will do, we will simply set front and rear is equal to 1 to make it the queue empty. Else what we will do, we will increment the front pointer, and as you know, when the front index will reach at the end of the array, we need to set it back to 0 index. So for that purpose, we will take its mod by the size of the array. So this is the function of DQ, and finally we write another function that will show the peak value or the front value of the array of the queue. Its name, let's define its name as peak, int peak. Here we again check if the queue is empty. We will say queue is empty. Else, and when queue is empty, we will simply return -1. Else we will return the value that is at the front at that time. So this is it, and now let's check. I create a queue, name it my queue, with size 5, and now I enter some values into the queue, and queue some values 3, next 4 or 34, next 7, next 9, next 1. So we have entered 5 values, we have enqueued 5 values. So now the queue is full. Now if we try to enqueue another value, it should give a message that queue is already full. And now let's check. So here is sending the message queue is already full when we try to enqueue the 6th value. So now we see what is the value at front. 3 should be served first, it should be at peak. So let's see. My queue dot peak, it should return 3. So that's it, it's returned 3. So 3 is at peak or at front. And so now let's DQ the values. DQ one value, it will DQ 3. Next DQ, it will DQ 34, DQ7, DQ9, DQ1. And now if we try to DQ another value, it should give the message that queue is already empty. Yes, now it's giving message queue is empty. So now let's write another function that should display the queue values. Here we define it. Right, let's name it display void display. And what should we do to display the values? We can simply take the values at the front. So this is the front. We assign this front index to some variable I, and we will then increment I one by one, and we will keep on displaying these values, and when the I will reach the real value, we will break the loop. So this is simple logic. Int I is set to the value of front while loop is true. We will show the value as at I index. Let's give some space here, and next we will increment I plus 1, and when I reaches at the end of the array, because it's a circular array, it should set back to index 0. To do that, we will take its mod with size, and so this is the loop. So where should we stop this loop? If I is equal to rear, it means rear has been displayed as well. At this point we can break the loop. This is it. So now let's display the values of this loop at this point, because we have not dequeued anything. So at this point you should display all these values. Display let's have some line break. So at this point I should display 334,791. So 334,791. So here it goes. So that was it. It was a circular queue implemented using the array data structure. So stay tuned for next lectures.